Welcome back to our TypeSpec tutorial series. I'm Mario Guerra, the TypeSpec product manager at Microsoft. In this video, we're going to dive into defining operations and responses for our Pet Store API. If you missed the first part, make sure to check it out to get up to speed with installing the necessary tools and setting up your project. If you'd like to follow along with the tutorial sessions, you can download the session files from aka.ms/typespec101/files. This will give you access to the end result of changes made to main TSP for each video. You can easily cut and paste from these files to follow along and implement the changes as we go through the tutorials. So what exactly are we covering today? Specifically, we'll be defining CRUD operations, create, read, update, delete, for our Pet Store API. We'll also discuss the benefits of using nested namespaces to keep our code organized and easy to manage. I'm going to start with a simple get operation to read a list of all pets. Here's how we define it in TypeSpec. The route decorator defines the base path for our pets resource. The get decorator specifies that the list pets operation will respond to get requests. The operation returns a status code of 200 and a response body containing an array of pet objects. There are similar decorators for put, post, and delete requests. We've defined our get operation within the context of a nested namespace named pets. Using nested namespaces in TypeSpec keeps our API organized by grouping related operations together. We've also given our get operation a unique name similar to a function name, so the operation translates to a unique operation ID in the OpenAPI spec. Because we've defined our operation in a pets namespace, the namespace and the operation name will be combined to produce an operation ID named pets_listPets in the OpenAPI spec, making it clear that this operation is related to the pets resource. That same convention will apply to all the operations we define within the pets namespace. Let's add more operations to our pets namespace to complete the CRUD operations for our pets resource. Here's what the route URLs will look like for the CRUD operations we just defined in the pets namespace. All the operations are available under the pets base path. We can list all pets or perform specific operations on individual pets based on their IDs. In a real-world API, these operations would likely return different types of responses. Let's see how we can specify multiple response scenarios in TypeSpec. We've updated some of the operations to use the pipe character to define multiple possible responses for the operation. For instance, the createPet operation can return a 201 status code with a new pet object, or a 202 status code with an accepted pet object if the pet already exists. Let's see how these TypeSpec definitions map to the OpenAPI specification. On the left, we have our TypeSpec definitions, and on the right, the corresponding OpenAPI spec. 66 lines of code in TypeSpec, 131 in OpenAPI. As you can see, TypeSpec provides a much more compact way to define API operations compared to the equivalent OpenAPI spec. This makes it easier to read and maintain your API definitions. I want to take a step back and describe what the flow of operations look like to clarify what TypeSpec is doing for us. TypeSpec is describing the interface of our API service in the form of operations we can perform on our pet's resource. When a client makes a request to that interface, the backend service code you write separately will handle the request, interact with the database, and return the appropriate response. In this video, we demonstrated how to define CRUD operations for your REST API using TypeSpec and discussed the benefits of using nested namespaces. We also covered how to handle different types of responses. In the next video, we'll cover how to add error handling to your REST API.